Okay, welcome to page 2 after all the blurriness and nonsense. All right, given the reaction, blah, 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 how can you tell a reaction took place? Well, if you give me this reaction, I can see that there's a rearrangement. Rearrangement of atoms. But if I was just watching this reaction, I see H2, and that is a gas, so this would be bubbling, giving off a gas. And so the same thing can be said of the second one. You see, there's a rearrangement, so I'm just going to put, quote, quote, because that's the same as up here, a rearrangement of atoms. I can see that there's a rearrangement of atoms. Carbon is no longer with hydrogens with oxygen. But if I was just watching this reaction, I would see that water is produced. And that's how I would know. If water is produced, it is definitely a reaction took place. Okay, you are given the following information about a sample. Which piece of data can you use to identify the unknown substance? Okay, so the only one that's going to be unique to an element is going to be density. More than half of the periodic table is solid, so that one is not going to work. More than half of the periodic table is silver because it's mostly metals, right? From the left of the staircase. So being silver isn't going to help me identify anything. I can get 6.64 milliliters of anything, so that doesn't help me. 5.78 grams, nope. 3.2 centimeters, I can measure anything and it doesn't matter. So density is the only thing that is unique to that element in that list. Okay, a sample is a temperature of 50 degrees Celsius. Ooh, hot. Has a mass of 5 grams, a density of 2.1 grams per milliliter, is silver in color, and has a volume of 2.38 milliliters. Which piece of data can be used to identify the sample? Well, again, temp doesn't give me anything. Grams doesn't give me anything. Aha! Wow, they use the same answer twice. Density. Density can help me identify it. I mean, all of these can help me identify it. Silver can help me identify it as a metal and not a non-metal. 50 degrees, if I watch how fast it cools down, I can tell you what metal it is exactly. So don't get too hung up on, what they're asking here. Density is the only one that, as given, if you had this unknown stuff in a box and I couldn't see it and you just gave me this list of data, that's the only thing that I could really use, right? What is the density of water? It is 1 gram per milliliter. Hopefully everybody knows that, or 1 gram per cubic centimeter, your choice. Will a substance with a density of 0.5 grams per milliliter sink or float? Well, I'm assuming they mean in water, and so I'm going to say, oh, what am I doing? See what happens when you get me after class? Oh, it floats. It's less than 1. So anything that is less dense than water is going to float. So that means lower. That means 0 to 0.9999999 is going to float. And anything greater than 1 is going to sink. So determine which of the following will float in water. 1.6 grams per milliliter is greater than 1, so it will sink. 0.97 will float. 3.5 grams per milliliter will sink. And 1.1 gram per milliliter will sink. Okay, a student was given an irregular shaped object with a mass of 42.3 grams. All right, so I've been given an irregular shaped object. I'm going to draw an irregular shaped object, and I'm going to say that it weighs 43 grams. After placing the object, wait a minute, a graduated cylinder has an initial volume of 25.4 milliliters. I like drawing things. 25.4 milliliters. After placing the object in the cylinder, the volume rose to 65.4. So I put my object, slightly different, it's closer. I put the object in the water, and the water rose to be 65.4 milliliters. calculate the density. And density is equal to mass over volume. So I have a mass. And indirectly, I have a volume. If I subtract the initial volume from the final volume, 65.4 minus 25.4 equals 40 milliliters. Now I have a volume. And if I do on 43 divided by 40, I get 1.075. 1.075. Oh, it's 42.3 grams. Gah. See? Don't write down just anything you want. Erwin, it's 42.3 grams. 42.3 divided by 40 equals 1.5. Okay, that looks more correct. 1.0575 grams per milliliter. And that, dang it. Now you know what happens in my classroom when I take people's pencils away from them momentarily. I break their lead. Yep, so density is mass over volume. I've got a mass. I calculated a volume by subtracting the initial from the final to give me the actual volume of the object. And then I just did the density problem. Everybody by now knows what the density problems look like, right? All right, so here we have a density column. We have 1.3, that's going to be on bottom, so that's dichlorobenzene. And then I have 1.3, wait a minute, and I have 1, which is water. And then I have 0.7, which is gasoline, 0.7. Why do I keep trying to write the density in here instead of the actual substance? And then they're asking me where this thing would end up. Well, 1.05 would be in between these layers. So it wouldn't end up in any layer. It would end up in its own layer, 1.0575. Whatever that object is, it would sit between these two layers because water is 1 and this is 1.3 and this is slightly in between them. So it's not going to be in any layer. It's going to be in between the layers. Okay, in between water and dichlorobenzene. And that's page number 2.